light meter is measuring visible light, one of the most common forms of radiation. Because we live, work, and play in sunlight, it would be almost impossible to avoid this kind of radiation. And there's no need to, because it's healthy and we enjoy it. However, when sunlight is strong enough and you stay out under it too long, you can be burned, and sunburn can even cause death. But since we can control the amount of sunlight we get and shield ourselves from it when it gets too hot, we can enjoy all its benefits and avoid its harmful effects. This survey meter is detecting another kind of radiation, called nuclear radiation. Although we can't see or feel this type, the survey meter can detect even the tiny amounts given off by a luminous clock dial. We're exposed to this type of radiation every day. Some comes from the radioactive materials in the Earth and outer space. Some comes from our use of radioactive materials in medicine. And still other sources are the radioactive materials we use in industry. The X-ray machines used by doctors and dentists give off a very penetrating type of radiation. These X-rays can be very hazardous, particularly for those working continuously with them, if proper precautions are not taken. But because we can control them, we can use them for our benefit. For example, one way we can control them is by seeing that the duration of exposure is reduced to a minimum by limiting the time the machine is on. Another way we can reduce exposure to the operator is by placing the switch that operates the machine in another room or behind a heavy lead shield. This actually provides double protection. First, it puts distance between the source of the radiation and the operator. And second, it places a shield between him and the radiation. Thus, there are three different ways of getting protection here: by controlling the time, by using distance, and by providing shielding. These same factors which provide protection against X-rays can also offer protection against nuclear radiation, specifically the gamma rays, which are the most hazardous type of radiation from fallout. In making use of the time factor, we can't shut off the gamma radiation from fallout, but we can reduce the radiation dose by decreasing the period of exposure. Thus, if work has to be done in a high radiation area, it should be carefully planned to minimize the stay in the contaminated area. Another way we can use time as a protective measure is by taking advantage of the decay of radioactive materials in fallout. The curve on the graph indicates the radiation levels during and after the deposit of fallout. This will give you an idea of the rate of decay. If the radiation levels 7 hours after the burst were 100 Roentgens per hour, at 7 times 7, or 49 hours, about 2 days, the level would drop to about 10 Roentgens per hour. And at 7 times 49, or 343 hours, 2 weeks, the level would be down to about 1 Roentgen per hour. After this, it takes a long time for any appreciable drop in the radiation level. Thus, by the end of a 2-week period, we have taken full practical advantage of fallout decay. In order to protect ourselves until the outside radiation drops to a tolerable level, we must rely on the shielding and distance protection provided by fallout shelters. The best means of protecting ourselves from gamma radiation is by shielding. And the principle of shielding is to provide a sufficient barrier between us and the fallout to reduce gamma radiation to tolerable levels. Almost any barrier will absorb some radiation and reduce the amount that passes through. For example, even a sheet of tissue paper held in front of a light cuts off some of it, and as additional sheets of paper are added, less and less light comes through, until we have a barrier thick enough to completely cut off all the light. Some substances form better barriers or shields than others. For example, a thin sheet of aluminum foil eliminates almost all light. The same general principles apply in shielding ourselves from gamma radiation. In this case, the effectiveness of the shield will depend upon the weight or density of the material, as well as its thickness, because the shielding is intended to absorb gamma radiation. Thus, the shielding efficiency of materials can vary greatly. Of the more common materials considered here, lead is the most effective. Then steel. Then concrete. Earth. Water. And finally, wood. Although a large part of the protection provided by fallout shelters comes from shielding, distance, sometimes referred to as geometry shielding, also plays an important role. Notice how the intensity of light drops as we move away from the source. Distance can also be used to reduce the radiation level from gamma radiation. Thus, high buildings furnish us with valuable protection against fallout on the ground, because shelters can be located in the upper stories. However, even when we can't escape radiation by getting far away from the fallout, most of our large buildings can still offer considerable protection by enabling us to take advantage of all three factors: time, distance, and shielding. It is the combination of these three principles of protection that has made our shelters and the shelter program the backbone of civil defense.